Thank you for those opening comments. Actually, Mike was helping me a little bit connect those dots. I understand you have a long-term relationship with Mike Dunn with Geophysical Insights, who will speak a little bit later this afternoon. As well as I should offer at the outset, Dr. 𝗣𝗿𝗱𝗁, a name I'm sure you guys will know, is an advisor to our firm, actually around CCS initiatives. I'm Hal Green, and I manage marketing for Geophysical Insights, and it's a pleasure to welcome you all here today. What I'd like to do is just take a few minutes, in addition to introducing our speakers, to talk a bit about how we got here and give you a kind of a high-level overview of the 𝗣𝗿𝗍𝗂𝗰𝗁𝗂 AI workbench. So on behalf of my colleagues, we see this as a kickoff meeting to effectively an expansion of our relationship with UT and the BEG, the catalyst of which is AI-enabled geoscience workflows. It's really why we're here today. We want to talk about those workflows. And while these workflows are supported by the 𝗣𝗿𝗍𝗂𝗰𝗁𝗂 AI workbench, thank you for that initial plug, this is not, to be assured, this is not a commercial, software commercial. It really is a briefing, a technical briefing, in fact, on how machine learning and deep learning technologies are transforming our industry. So with that, let me just advance the slides. Oh, they're already up here. I'd like to talk a little bit about our agenda today. So our presenters are going to share theory, a little bit of theory, no equations, I don't think, but a little bit of theory, practice, complemented by ample case studies, and a good balance of those. So this is a very practical set of discussions. Robin 𝗍𝗻𝗍 will be up shortly. Many of you know him, senior geomodeler at the BEG, and he'll share some of the excellent work that he's doing in the Permian on using the 𝗣𝗿𝗍𝗂𝗰𝗁𝗂 AI workbench, particularly around predicting lithologies using machine learning. And that's his results, I'd like to say, are quite dramatic, and I think you're going to be very interested in that. Following Robin's talk, we'll have a short break, and then we'll hear from 𝗣එහෙ𝗿𝗍𝗂𝗰𝗁𝗂 here on the front row, who's the current president of AAPG. And Deborah's talk will be on estimating reserves and visualizing depletions using machine learning. That topic, of course, is going to appeal to geoscientists of all stripes, as well as engineers. By the way, can I see a show of hands? How many of the students here are geophysicists or majoring in geophysics? Okay. Geology. Okay. Engineering. Okay. Oh, good. So yeah, a lot of our content today, I think, is going to be very appealing to the engineering community. 𝗣VRO_𝗱𝗂𝗰𝗁𝗂 will follow Deborah, and he is the architect of machine learning lithofacies prediction in 𝗣𝗿𝗍𝗂𝗰𝗁𝗂. And he'll describe how this methodology is faster than statistical inversion. I go so far as to say 𝗣VRO is going to prove how it is faster than statistical inversion, and we believe more insightful, better, more detailed than statistical inversion. In fact, I'll just give you a little bit of a hint of that, of our work here across the world right now in major projects worldwide. We're doing lithofacies prediction in a month. Projects that we know would take 6 to 9 months. And again, 𝗣VRO_𝗱𝗂𝗰𝗁𝗂 is going to speak to that in detail. He'll be followed by Dr. 𝗍𝗁𝗁𝗁𝗁, a senior data scientist and researcher, who will present 2 deep learning workflows, fault detection, which centers on synthetic fault models, and seismic facies classification, both of those enabled by convolutional neural networks. And Jay is well published on those, several papers on those topics. And in fact, one of those papers includes a publication in 2020 on synthetic karst models, as I understand, Jay, and that was done with some investigators here at UT. He was an author on that work. Mike Dunn, Senior Vice President, will be the capstone talk of our afternoon. We'll speak to and share insights around ways of getting started with 𝗣𝗿𝗍𝗂𝗰𝗁𝗂. How do we get started? How do we get our arms around this? So let me catch you all up on how we got here in 2022, just coming out of COVID, we granted a modest number of licenses to UT. Robin, I think that you facilitated that as well, it seems to me. And Robin contacted us again last year. I think he was sensing a need to expand the footprint of 𝗣𝗿𝘁𝗱𝗂𝗰𝘁 at UT, and we increased the licenses to the 50 units that Dr. Schuster had referenced earlier. Then at Image 2024, actually at our booth, Dr. Young came over and helped us out with a joint announcement to the industry and to the press about our expanded relationship, and we began to set in place a plan to train more of the faculty and students in 𝗣𝗿𝘁𝗂𝗰𝘁. We worked with Kristen Tusek and her office, thanks Kristen, in both getting the word out and in fact organizing this event today. And Kristen continues to be a focal point in our discussions with UT. So we see this investment in UT and the BEG as a way of enabling the next generation of geoscientists and engineers to experience using AI software, commercial off-the-shelf software for subsurface analysis while supporting both instruction and research in that area, publication and research. And we also are aware that many of the initiatives at UT are focused on decarbonization methods, and we look forward to seeing the work product from that analysis as well. Now, a little bit about Geophysical Insights. For those of you that, I'll just go ahead and get this all up here, don't know us, we were founded in 2010 by Dr. Tom Smith, who, by the way, would have been here today, but is ill, recovering, but is ill and is unable to make it. He sends his regards. He would have loved to have made this, I'm sure. Lives right here in Austin. But he founded the company in 2010 with the vision of applying this emerging, back then, 2010 really, technology around machine learning to the problem of seismic interpretation. And he had been working with some of the thought leaders in the industry like Turi Tanner and Sven Treitel on this issue, and they had published a bit around that topic. And he set about, having sold his previous company, to invest some energy in this space, at this intersection of machine learning and seismic interpretation. Well, 3 years in development, we launched 𝗣𝗿𝘁𝗂𝗰𝘁 in 2013 at SEG that year. And we were one of the very few companies with a commercial off-the-shelf product that used machine learning. That remained to be the case until about 2016, that when other companies joined us. We're in a marketplace, and marketplaces make us all better. It's a good thing. But we still remain, I believe, the Geophysical Insights and the 𝗣𝗿𝘁𝗂𝗰𝘁 Workbench maintains a leading brand position, so to speak, worldwide in the industry. And we have expanded 𝗣𝗿𝘁𝗂𝗰𝘁 to include more machine learning and deep learning technologies, as I've referenced, that we generally now refer to that collection of technologies as AI. And on the far right side of the chevrons on screen, you can see our direction is geologic specific automated workflows. So we are building in more automation to enable the interpreter to spend more time analyzing the results and less time, frankly, having to manipulate software. So my colleagues are going to speak more to this subject of the details today about these workflows, but let me just give you a view of our stratigraphic analysis workflow. We say thought flow, and we have invested a great deal in the software to make it straightforward to use for disciplines of all stripes, and really people at all points in their career. This left to right construct guides the users through this analysis, showing what steps need to be taken next. The buttons in the light gray are completed. Those in the goldenrod color are current, and those in the dark gray must still be done. And because of this ease of use, 𝗣Paradise can be applied, as I said, by disciplines of all types, engineers included. I myself am an electrical engineer, got my undergraduate from Texas A&M University, if I can say that in this holy place today. Even I can use 𝗣Paradise a bit. So guided thought flows. Now, by using these tools, here is the premise, and I invite you to check us today on these ideas. By using these tools, geoscientists and engineers are able to get the following results: generate seismic, pretty much any seismic attribute that's needed. Run fault detection analysis in minutes or hours compared to weeks, what it used to take manually, picking faults. Reveal features down to a single seismic sample. Yes, down to a single seismic sample. And again, I'm going to put this on 𝗣𝗿𝗱𝗂𝗂𝗃 to prove momentarily here. Compare well logs to machine learning and deep learning results to QC those findings. Predict lithologies across a region. Classify seismic facies. Identify geobodies and calculate volumetrics on those geobodies early in the interpretation workflow. The results are straightforward. Users can leverage AI capabilities to analyze the subsurface faster and at greater detail than traditional methods. And I, again, invite you to check us on that premise. These icons represent the applications on the 𝗣Paradise AI Workbench. Time doesn't permit me to speak to each of these. However, as I indicated in that previous screen, what we do in the thought flows is pre-arrange these applications basically for specific solutions like stratigraphic analysis, fault detection, and lithofacies prediction. The premise underlying all of these is simple and I think powerful. That again, more can be seen in the seismic response and the well logs I'd maintain using AI technology in all geologic settings than traditional methods. Now with that, I am delighted to introduce 𝗤𝗏𝗍𝗻. Robin?